This lesson is polar coordinates. I will do this in 4 parts because it's very lengthy. Okay, so this is part 1. Here we have an example: convert polar coordinates to rectangular coordinates. So this is the example. This is what polar coordinate looks like. You have a number followed by a radian degree, a degree in radians. Okay, so this first value is the r. The second value is your degree, and it's always in radians. Okay, so one more time: polar coordinate. This number is always r. This number is always your angle or theta. It is always in radians. However, radians is more difficult to visualize, so change it into degrees. So negative pi over 4 is negative 45 degrees. Now let's put this point on the graph. Okay, so here's my y, here's my x: 0, 90 degree, 180 degree, 270 degrees. Okay, so 0 going up is positive, so 0, positive 90, positive 180, positive 270, and then back to positive 360. However, this is negative, so negative, you will go down from 0. Okay, negative, so go down from 0. So here's 0, because it's negative, go down 45 degrees. Okay, again, negative, go down, positive, go up. Okay, this is my r. R is 4, but over here it says negative. Remember, r is always positive, never negative. Okay, even though there's a negative here, but r is always positive. So what does that negative do? Note, r negative means flip to the other side. Okay, so remember, r is always positive, but if there's a negative, you're gonna flip it to the other side. So right here, this line right here, just flip it to the other side. Okay, one more time: negative 45, start from 0, because it's negative, go down. If this is positive, go up. Since it is negative, go down from 0. So here's negative 45. R is negative 4. Remember, R is always positive, never negative, always positive. What does that negative do? The negative flip to the other side. Okay, when r is negative, you flip to the other side. So this is r, and this negative 45, flip it to the other side. So the red line is the actual location. Okay, the red line is the actual locations. Okay, so negative 4 comma negative pi over 4 is the same as negative 4 comma negative 45. Okay, so this is in radians, this is in degree, same thing. Okay, I will explain later where did the 2 square root 2, negative 2 square root 2, just a little bit. Okay, so the red line is the actual location. Negative, so you go down. R is always positive. Since there is a negative, negative means flip to the other side. So here's the place where it was. Because r is negative, it get flipped over to the other side. Just flip it over. So this red line is the actual location of negative 4 minus pi over 4, or negative 4 minus 45 degrees. Okay, 2 square root 2, negative 2 square root 2. I will explain it just a bit. Okay, all right, so that is the graph of negative 4, negative pi over 4. Okay, so polar coordinate, r go first and then the degree. Polar coordinate, r go first and then degree. Okay, and degree is always in radians. However, radians is difficult to visualize, so change it to degrees. Okay, so this is how you convert polar to rectangular. Follow this formula. X is always r cos theta. X is always r cos theta. Well, we know what r is. R is negative 4. We know cos theta is, which is negative 45 degrees. negative 45 degrees or negative pi over 4. Okay. Now so use your calculator or chart. Okay, use the calculator or the chart, and it will come out square root 2 over 2. -4 is just -4. Cos negative pi over 4. Okay, use your calculator or the chart. Okay, way back then in chapter 7. Or you can go online and just type in trig table, and it will show you that it will be square root 2 over 2. Okay, so make sure you use the chart. And then 4 times square root 2 is just 4 square root 2, but there's a 2 in the bottom, so I can cancel. So 4 divided by 2, that's where the 2 comes from. One more time, 4 divided by 2 gives me 2. And then square root 2 just stay as is. Don't forget the negative. Okay, so one more time, negative pi over 4. How did it become square root 2 over 2? Use the trig table chart. Okay, it's in your PowerPoint back in chapter 7. Or if you don't have it, you go online, just search it for it. Okay, next, y is always sine theta. Y is always r sine theta. Okay, one more time. Y is always r sine theta. We know what r is, -4. We know what sine is, negative pi over 4. So same thing. How did negative pi over 4 become square root 2 over 2? Use the table, use the chart. Okay, and then -4 divided by 2 gives me 2. One more time, -4 divided by 2 gives me 2. Negative times negative is positive, square root 2, leave it alone. Okay, so 4 divided by 2 gives me 2. Negative times negative, positive, square root 2, leave it alone. And that's where I got the x and the y came from. So here's my x, here's my y, x, y. That's where I got this from. Here's my x, here's my y. Okay, so let's rewrite this. So here's my polar coordinate or point. Okay, this was given to me, r, theta. I want to change it to rectangular, so x, y. Polar, rectangular are the same location. It's just written in different format. One more time, be very, very careful. Polar has r, theta. Rectangular has x, y. Okay, polar, rectangular are the same location. It is in the same location. Do not be confused that they are different. It is different in writing, but same location. Okay, so this is polar, this is rectangular. Different writing, but same location. Okay, so be very careful. And again, this formula right here is to get x. This formula is to get y. Where did the negative square root 2 come from? Use the trig table. Okay, it is in chapter 7, beginning of chapter 7. If you don't have it, go online, just type it up, search for it, and it will come out this value. Okay, same thing here. All right, same thing. Okay, all right, so be careful. This is how to convert polar to rectangular. Polar, rectangular. Okay, different writing, same location. Okay, now also be very careful. R is always positive, but if I have a negative, that means you have to flip this to the other side. Okay, so the red line is the actual location of -4, comma, negative pi over 4. Okay, radians is difficult to visualize, so change it to degree so you know how to visualize and where to go. Okay, so this is the first part. Okay,